Okay, so we're going to uh, start with statistical inference. Welcome to 2015 and data science classes. Now, before we start, there's one thing that I wanted to tell at least all the first yearites that you have more time on your hand, and I guess all of you should be coming to classes. This will allow you to complete the data science specialization, plus, it opens up a new venue for you next year in the job scenario. Because things are moving now, and a lot of startups are coming up, and so there is a big advantage there. Like for example, Lavita was telling me that Anisha has already got a summer placement in one of these analytics companies. And in fact, she applied for two, three of them, and all of them agreed. And so she was supposed to pass on those links to you guys as per my talks with Lavita. So the point is that if you guys, since we can continue our classes till maybe April and all, and we finish off all the 9 courses, and then you start doing the project. The project associated with the capstone for data science. So you will be in a good shape by say maybe August, etc. As far as data science is concerned. And there are times when you feel that this is coming too much, and it actually is too much. So don't worry about that. Basically, just keep doing it. And when we revise courses, suddenly you'll see that things are falling in place. All right. So right now we kind of just covering up the thing, and there'll be a rough draft of our learning, and we can always create a finished product out of it. With a second revision, which can be much faster. Right. So for example, the data science, the statistical, and what is so amazing about the data science classes on Coursera is that what I found is there's one thing which is regularly being used by people to learn data science, and therefore the courses are improving. So for example, the same course, that is statistical inference, I had joined it last month, all right, and so I didn't finish it. I had completed everything. I missed out on the deadline for the project, because it's a hard deadline. So I was late by an hour or so. So I enrolled again this time, and I noticed that they have added new lectures, they have changed certain things. So the professors behind the scenes are working on improving the course every month based on the feedback from the students. And this is a course which, I mean, the whole specialization is such that all the 9 courses are getting offered every month, which means all the courses are getting improved wherever there's a need from the feedback from the students. All right. So this is a very amazing syllabus also that we have in hand, which is continuously improving. All right. So if you were to follow a book or anything, once a book is written, that's it. Okay. So I would say value it, know that you are doing something very special. I mean, and I think you will value it even more when once you pass out. Once you pass out, you will realize that there's something very special that you ended up learning in the college. Okay. So having said that, when an ecosystem is there wherein everyone is coming together, you'll be liking it. Say all 12 of you coming together, like say, so suddenly you feel that yes, there's a classroom going on. Maybe you start sitting in one single room or something like that. You know. So are you with me on this? Maybe I've kept your speakers on. Maybe you can talk to me. And another thing that we tested is that even if the speakers are on, as long as you guys are using some good quality headphones, all of us can talk to each other. So as long as we maintain some discipline, so there'll be no different. We don't. You don't. Guys won't even need to chat. For example, Lavita and Pratik's speakers are on. Dipankar has muted it. So if you so this is another thing that I would want you to I bought a very good pair of headphones which I use uh, for my phone, right? Mainly for the phone. It's a Philip thing which is available on Flipkart. I'll send you the link. It's about some 500 600 bucks, but it's good. I mean, it has a microphone as well as a speaker, and good for the purpose of at least using it. Like for my class, I use a different one. I use a professional headphone and speaker. So the for the class it is different, but for what I use in general for for my mobile, etc., is a different one. So I would recommend all of you to buy that instead of using the phone's microphone. Sorry, your laptop microphone, because the laptop microphone catches the other sounds as well. All right. So is that fine as far as the equipment that you will need to use? Because I would like that every one of you are on microphone as well, and you can call back and talk back to me. Uh, Lavita, Pratik, can you guys uh, say something? I have I think Lavita and Dipankar has muted themselves, but otherwise, it, I can still hear. I think maybe Pratik is on unmute, right? So can I hear some of you guys? It doesn't matter, Dipankar. You switch on your. So can you talk back? So we can test this that it's working fine for at least
Yeah,
three
I
of
can.
us. Okay, Dipankar. So you also
Yeah.
the rest of you could also hear Dipankar. Lavita and Pratik, you could hear Dipankar. Pratik, you don't have a headphone microphone, is it? Yeah, but you don't have a microphone, is it, Pratik and Lavita? Oh, you're getting ready to speak. So maybe you can just talk back instead of chatting back, so others can also hear you. So why I'm saying is let's just utilize some of the time to set up things so that our efficiency is better. I still can't hear either Lavita or Pratik. Are you guys making some setting changes or something? No, I can't hear you. Dipankar, you can hear
Yeah,
Lavit,
Randy only.
Lavita?
No, I can't hear.
No, mic headphone is with two pins, one for mic, two for headphone. Okay. All right. So Pratik doesn't have a mic, but Lavita, I can't hear you through your microphone. Looks like your microphone is not on or something. Chaturmali, can you speak through your microphone? So fine. So I'm keeping this in
Can
recorded.
you?
Yeah, I can hear you. All right, good. So basically, what we do is whoever wants to speak, probably just say allow, and I will give you immediately. I'll give you the microphone rights. All right. So that way anyone can speak. For now, we will keep everyone on because I don't see any background noise at all. So everyone is on microphone. Anyone can speak at any point in time. All right. So and interrupt me, and we can do it like that. So good. So this is another point that I want to make, that all of you should buy a good headphone and a microphone. It costs you about 500 $600, so everyone can be in the class with the microphone. So okay, so having said that, so let's begin. Okay, so a little bit of interest building for statistical inference and statistics. Now statistics was one of my hated subjects in my MBA. When we were doing it, and even earlier, I would find it such a time waste to have to use the calculator and calculate the standard deviation, first take the frequency, and such a menial kind of work that you're supposed to do whenever we learn statistics. And I would notice that 90% of the time would go into that. So. That was the reason. But suddenly, when I started doing it again here in Coursera, what I noticed is that all that work is being done by R for me, and because the software is doing all the calculation, I don't have to spend time on that. All my energy is going in understanding things, using the fundamentals of statistics, understanding them, and coming up with something very wonderful. And once I started doing that, suddenly statistics has become very, very interesting. In fact, what I found is that statistical inference is probably one of the most interesting courses in the data science series, because all this while it was about R and learning skills and tricks in R, and this is the first time we are using some domain knowledge to then kind of understand it better. So in statistical inference, we are still understanding statistics rather than doing anything else, but we are actually understanding it in depth because of R. All right. And for the first time, I think I found a combination wherein I have the software at hand. At the same time, I have something which is totally to do with maths and science, and something intellectually quite challenging. All right. So that's how it is. If you guys also start spending some time on this topic, you will start finding it very, very interesting. And if you ever plan to become analysts, I feel that your statistics fundas should be super strong, because statistics can be super scary for people whose fundas are not strong. They will find it meaningless, why they have to use this test and that test, and all those big names. There'll be Welsh test and T student test, etc. But if you are clear with these fundamentals, you will immediately recall the math behind what is happening this, and that will make it really interesting. Are you clear with me, all of you? Are you with me on
Yes.
this? Okay, great. Yeah. So having said that, let's look at what is there in us for the course here. So now this particular syllabus by Brian Pafo, by the way, it's quite loaded. He has provided a lot of things, like he has the swirl programming assignment, and then he has these homework, questions, etc. So for every week, and then he has a project, and then 4 quizzes. So there are no assignments. I mean, yeah, there's basically one assignment. There's a project, and then the quizzes. All right. And my idea is that we should take not more than 13 days. What we will do is we will do a class every day. So Saturday, Sunday including. So maybe roughly 10 days. So in 10 days, we pick up each topic and we finish it off. So, I mean, today I plan to cover at least 2, 3 topics. All right. Because they are very simple ones. And that way, so what happens is, say we spend 10 days in a month learning something every single day, and we finish the course. So that way it allows you to focus on it totally. Everything is fresh in mind every single day, and then the remaining 20 days are there with you to cover up other things, right? So I thought that this would be a better strategy than either alternate courses, alternate day classes, or even
Yeah.
daily classes that we were having earlier. What do you think about this strategy? Do you think we want to try this out in this time, wherein we say everyday class? Is that fine?
We can try actually, yeah.
Okay, good. What about the rest of you? I think that was Chandramouli, right? So,
Yes, yes, ma'am.
Lavita. Okay, good. So, Lavita, Pratik, Dipankar, do you think this will be a good idea? Wherein we just kind of, it's like, okay, so 20 days you have. In fact, what I will have is I will have those 20 days to kind of prepare the next course.
Yeah.
So, this sounds good to all of us? Okay. All right, great. Okay, so having said that, so let's uh, begin with our class. Uh, so I'm muting you all because somebody has a cough, and it's not disrupting my flow as such, but I thought that maybe in the recording it may not be a good idea to keep it. Okay, so okay, so we have these topics that are there in statistical inference. One is probability, and we will look at that. Then conditional probability, expectation values, variance. All right. So these are the concepts that you would have learned even earlier, I guess. And then we have some common, distributions of data. Again, it will not make sense without knowing any of these things. And then different other concepts, like we'll do test, like hypothesis testing. All right, and things related with these testings. Okay, so let's begin with what is statistical inference, an introduction to the topic today. All right, so basically we're saying that inference, right? So basically inferring something, we're saying that we have uh, uh, huge data that we want to infer about. All right, but we can't say for example, if we want to know the height of the population, now we can't go to every single person on the planet and measure it and then add everyone's height and take an average, right? That'll be a very almost impossible process. So what do? We take sampling, right? And we should be able to, from that sample, we should be able to infer something or deduct something about the overall population, right? And that is what is called statistical inference. All right, so basically we say that there is some uncertainty because we still have just the sample, but we should be able to account for it, wherein we can say, okay, we say with this much surety that this is going to be the case. All right, so 95% chances are there, this is what is going to happen. 5% chances are there that this is going to happen, or say 97% chances are there that this is going to happen, or 99% chances are there that this is going to happen. So there's an accountability. We say, okay, we can account our uncertainty. Okay, so and so you can do some conclusions from data, right? So basically we are quantifying our uncertainty. All right, so the data is so typically it is because the data is incomplete. Sometimes it could be a case where it's a bad data, right? But mostly it is incomplete data because we really can't have all the data, as the example that I gave you, right? So so when you have all the data, then it is not statistical inference, right? You don't really require it. You can actually compute the values, right? So so now, when we use the word statistic, right? So what is that? Basically, uh, we have something called a random variable. I will explain the concept of random variable. Uh, let's say, uh, uh, if I say, uh, uh, if I say, let's say, uh, so I want to create a performer. Okay, so I'm creating a letter, right? In the letter, I say, uh, for So roll number, some fill in the blanks, all right? And then I say whose name is some fill in the blanks. Now suppose all of you have a roll number and you have a name, right? So now I'm keeping it as a variable, but this variable is not random. Say the name variable is not random. Based on the roll number that is chosen, I will have a one-to-one mapping, right? So is this clear? So the variable is there, but it's not random. But what's the random variable? The random variable is where the outcome is from some set, but we are not sure what the outcome will be. For example, we roll a die. So when I roll a die, I can get any of the 6 values, 1 to 6. So I'm sure the value will be between 1 to 6, but I'm not sure which value will come the next time I roll the die, right? So there is a randomness associated with it. So that is what is a random variable, right? So random variable can have any of the given outcomes, but a random variable will have certain properties, and we will look at that. So we can apply some of the mathematics to these random variables, all right? And we come up with another variable. Now, whatever variable we'll come up with, even that is going to be random, but that is a computed random variable, right? So we do some computations on the variables. For example, I say what is the average value of the coin toss, right? So if I or say, let's say rolling of a die, right? So now for me to know the average value of the rolling of the die, first thing that I need to know is what is the probability of each value coming. So assume that my die is a fair die, which means it is equally balanced in all the sides, right? So which is the probability of getting any value, whether it is 1 or 2 or 3 or 4 or 5 or 6, is 1 by 6, right? So if I look at this, so here I have values 1 to 6, okay? So I have my probability mass, which I say is varying from 1 to 6, all right? And so on. And then my probability is 1 by 6. Now this is what I call the probability mass function, all right? So this is for the rolling of a die. Similarly, if I was to draw the probability mass function for a coin toss, assume my coin is fair, right? So I have say heads and a tails. Now a random variable, now for heads and tails are not having any values associated with it, right? It is just categories. So it will be difficult for me to do any computations. So what do we do in a random variable? We assign the outcomes to a value. I say heads is equal to, let's say, 0. Okay, tails is equal to -1. I could do that, or the other way around, right? So I can assign, and then my probability is half, right? So this is called a probability mass function, PMF. Is this clear? So a random variable will have a probability mass function, right? So now, and then you apply some processes. For example, I take the average of all of these values. How do I take the average? I say 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 and so on, right? What is the value that I get? That will be the expected value of this random variable. Now expected value of a coin of a rolling of a die is 3.5. Now does that make sense? Can I ever get a 3.5 when I roll the die? I don't, right? So but it is basically saying that the average value is this. Okay, so there is a joke about averages. It says that there was this statistician, and he found out that the average height of the river is 4 feet, and that's why he drowned crossing the river. So I guess you got it right. So what happened to him? Because the average value was 4, not that the deepest point was 4, right? So average is just about taking an expected value where we're saying, okay, this is what is expected value, right? So my random variables have expected values. So now, so when I apply some deterministic process, like for example, I say measure the mean of the values, right? I will get additional random variables, right? So for example, I get a mean of x, which is 3.5. So there's another random variable. Okay. So though the outcome of the mean typically would be fixed on the is a fixed value, at least for a rolling of a die, right? But we will still call it a random variable. Okay. And now this has a distribution here. Even this will have some distribution. We will look at those things later. Okay, so this is what is the concept of a random variable. Okay, so now we are saying inferences can be of two types. One is Bayesian inference, which we will look at a little bit, and another is frequent in statistics, which is to do with statistical hypothesis testing. We will look at this also. We will look at confidence intervals as well. So we will be looking at all of this. Okay, so before that, just coming to probability. So outcomes of an experiment, all possible outcomes, for example, die roll, right? So 1 to 6. So the probability of the particular outcome is what? Number of ways the outcome can occur divided by the number of ways for all the possible outcomes. All the possible outcomes are 6. One particular rolling of a die, I'll get 1 by 6. Is this the correct way to do it? This is the correct way to do it. What is the assumption behind this? A very strong assumption is that the rolling of the die is fair. Assuming that the die is not fair, it's a loaded die, which means, let's say it is such that when I sit through it, the side which has 6 is heavy. All right, so there are strong chances of me getting the 1, because the side which is 6 is heavy will fall down, right? That will get covered, and 1 will come more often, right? So in that case, the probability of getting a 1 will be higher than probability of getting the other values, right? So when I'm using this formula, probability of particular outcome, it is only holding true if I assume that my die is fair. Otherwise, how do I come to these probabilities? Are you getting this? So my next question is, how do I come to the probabilities? How can I measure the probabilities of a rolling of a die? Say, for example, I have a die, right? I bought a game. Now, how do I know whether the die is fair or not? Are you getting the question? So how do even I know whether my die is fair or not? We keep on playing the games, but we never know whether our dice are fair or not. And that is what is going to change the quality of the game that we play, isn't it? Right? So for that, we will look at things later. How do you come to the probability function? For now, let us just say that, okay, we kind of know it. Let's say we know the probability function. Okay. So now the probability of an occurrence. So there is an event is occurring. Let's say coin toss. So the coin toss is occurring. That's an event. Either you get a heads or a tails. What is the probability of that event occurring, or a particular instance of that event occurring, right? Overall probability will be between 0 and 1. Say the probability of getting a heads is 0.5. So it's between 0 and 1. So now impossible events are, what we will say is that the probability is 0. And events which are sure, the probability is equal to 1. So then they will not be random variables. So we can define an event and its probability in this format. We say, okay, random variable will have a probability between 0 and 1, whereas impossible events is 0 and certain variables is 1, right? So we basically are able to convert everything into mathematics. What is random, what is not random. Okay, now there's the simple concept. When I say the probability of A and B, when both of them are independent occurrences, right, will be given by probability of A into probability of B. So let's say I'm rolling the die twice. So what happens there is, so I have these values. So I will get values from 2 to 12, because if I roll the die twice, the minimum that I can get is 2 ones, right? So I get a 2, and so on. The maximum that I get is 2 sixes, which means 12. So now here the probability distribution is going to be like this. The probability of me getting 2s is 1 by 36, because there's only one chance. Maximum possible combinations are 36, right? 6 into 6, and out of that, 1 is for one value of 2. Similarly, let's look at value of 5. So I get a chance wherein 1 and 4, 2 and 3, 3 and 2, and 4, 5 and 1. So I have 4 ways to get it, which means my probability will become 4 by 36, and so it becomes 1 by 9, and so on, right? So now this is what is called a probability mass function. So I can draw this as a probability mass function for the rolling of 2 dice. So the rolling of 1 die had a different probability mass function. Rolling of 2 die has a different probability mass function. So now again, the concept of Venn diagram. What I can say is the probability of A union B. So basically A or B happening is what? It is given by probability of A happening independently plus probability of B happening independently minus the probability of A and B both happening, right? So let's assume, so you can do some computation. This is it. So just know that the Venn diagram concept is followed by probability also. So I'm giving you mic rights. Okay. So far everything is clear?
Yes, bhaiya.
Actually, okay.
Yes.
So All right.
Yes.
Okay. Uh, any clarifications? Any clarifications? Okay, looks like fine.
Where you said
So
about
let's
averages, what is the
right.
significance? What is the significance of an average then mean? Why do we
Why do
take
we want to
mean
take the average? Why do we want to take the
if
average? That's
it's
what
not?
your question is, right?
Yes,
Yeah,
yes,
we will come to that. Why
yes,
do we even need
yes,
to take the
yes, Bhaiya.
average, right? But for now, just understand that we can take the average, right? So
Yes,
we say
yes,
that
yes.
okay, we can. So we say that some mathematics, if we were to do, let's say we're just playing around with this. We say okay, if I apply this mathematics and I take all the values in each value into the probability of it coming, and then what I get is an average value that is coming, right? So I'm saying okay, there's this concept of average value. We will look at what it does. Okay, moving ahead. So now, so this is clear, right? So now random variables can be, one is discrete, another can be continuous. So whatever we talked about so far is a discrete random variable. What is discrete? We can count the number of possibilities. For example, coin toss 2, rolling dice 6 possibilities, right? So for that, what we have is a probability mass function. What is what we shown here? So 1, 2, 3, 4, 5, 6. Here there's a probability of 1 by 6, probability of 1 by 6, that nothing in between. There's nothing between 1 and 2, nothing between 2 and 3, and so on, right? So this is what is a discrete random variable. So it is exactly equal to the some value. So the probability of getting 1, there will be it will be exactly equal to some value. Probability of getting 2, exactly equal to some value, right? On the other hand, what we have is continuous random variables. Just a second. So what is a continuous random variable? Let's say basically typically anything which is biological, right? Or time or a distance is all continuous, because even though you can use the measuring scale to measure up to some point only, but the value is still continuous. Let us say the height of, the length of all the leaves in a tree. Now if I was to use the minutest of the, say if I use a foot ruler, then I say okay, the length is up to millimeters, right? But if I start using the vernier caliper, then the length is up to hundredth of a centimeter, right? If I start using a more powerful instrument, the length will be up to maybe thousands of a centimeter, and so on, right? So basically the length is continuous, but we only, our measurability is discrete. So that does not make the variable uh, into a discrete variable, right? So basically all the values will be on a real line. So is this clear? Let's assume, for the sake of assuming, that we can measure up to 10 decimal places, which means how many data points we will have. Let's say I was to measure the length of of a uh, a neem leaf, right? I have a neem tree and I want to measure the length of a neem, of the leaves of the average length, right, on a particular tree. So what let's say I pluck some 10,000 leaves, okay, and I start measuring the length of each of these leaves, and I can measure the length using maybe an electron microscope or something, which allows me to measure uh, up to say 5 decimal places. Is this clear? So I can measure up to 5 decimal places, which means how many different possible values can I have? Let's convert it into, compare it with say discrete values. Say, let us assume that the maximum length of a leaf can be uh, uh, 10 centimeter, and the minimum of course is 0. Let's assume, right? So I'm saying up to 10 centimeters is my maximum length, and I want to measure my length in centimeters, and I can measure up to 5 decimal places of a centimeter, which means how many total uh, uh, different values will be there. Like when I'm tossing the coin, there are two values. In that case, in this possible measurement, how many values are possible? So I'm giving you mic rights, wait, or you can type the answer. Up to 5 decimal values, and my maximum value can be 10.
Okay. Mm,
So basically I can have a million data points, right? Even though I'm taking just say 1,000 measurements, let's say I pluck 1,000 leaves, but it is possible that these
mm.
1,000 leaves could be amongst any of the million values, because 10 raised to 5 into 10. Is this clear to all of you guys?
Yes.
So now
Then
so
next, yeah.
probability of right, the probability of each of these million values, I don't know, right? some of them could be 0, some of them can be very small, but on an average, let's assume that there's a uniform distribution of the probability, that on an average, then
Sure.
the probability of each of these values will be what? 1 upon a million, which is a very, very
Yes.
small number, right? So I get 1 upon a million. So now
Yes.
if I'm getting 1 upon million, now that becomes a very small number. So if I was to use this concept of, probability mass function, doesn't really work well, because that's what, so you understood the problem that I will end up facing when I use the real line. So what I'm saying is that if I was to say, okay, give me the exact probability of getting a value of the length, which is 1.12345 centimeters. So it would be a very small number, isn't it? Almost negligible. So because it's like, epsilon tending towards 0, right? So what happens is, with the continuous variables, I cannot use the probability mass function. So what can I say? I say, okay, look, what I can give you at best is, give me the starting point and the ending point, and I can give you the probability between that value. For example, I say, what is the probability of the length of the leaf being some value uh, when the length is between, let's say, 1.1234 centimeters and 1.235 centimeters. So what happens is, all the points between 1.1234 and 1.1235 get covered. In our case, because we are taking up till 5 decimal places, which means the points are 1.1234 0, 1.12341, 1.12342, and so on up till 1.123450. Are you getting this? So we have 11 data points there, but this is only because we could measure up to 5 decimal places. If we were able to measure up to, say, 10 decimal places, we will have, as high as a million data points lying there. Is this concept clear about continuous variables? So what we use instead is called the probability density function. So what I'm saying is that, let's assume I have a graph, some curve. Okay, so area under the curve between a lower value and an upper value will give me the actual probability of getting the value between these two. So this is what is called a probability density function. But the concept has come up just so you understand how we computed the rolling of a die. So same concept gets applied for continuous variables. So okay, so this is what is about continuity. Okay, so here is what I have just kind of explained it also. So for example, same thing. So this is called a cumulative uh, density function. So there's another thing called a cumulative density function. What is a cumulative density function? I say value, getting a value 1 or less than 1, right? So then it'll be 1 by 6. We're getting a value 2 or less than 2, then I get 2 by 6, because I can get value 1 and 2 also. Getting a value of 3 or less than 3, I get a probability of 3 by 6, and so on. Similar, so I draw the same concept, a probability density function, and from that I can also draw the cumulative density function. So cumulative density function will be a value of x1. So x, where x is less than equal to x2 and greater than equal to x1, right? So this is what, so basically it is area under the curve, right? So basically I can keep measuring this. So between h, so roughly it is like this, right? And so on. So what is cumulative density function? As I said, is the integral of the probability density function. Okay, so because what I'm doing is I'm keeping on adding the area, right? So notice this is important. So I'm saying it is the probability that x is less than equal to whatever particular value that I'm looking at, and typically this x will range from minus infinity to x or 0 to x. So for example, the length of a leaf, it doesn't make sense to say minus infinity to x, so we say 0 to x, right? And similarly we have the probability of capital X greater than x. What is that? That is nothing but 1 minus fx, right? Because probability, overall probability has to be 1, right? Total probability is 1, so therefore I can subtract it straight away. Yeah, okay. So now we look at different functions, PDF functions. What I'm going to do is I'm just going to touch upon it a little bit, and I'm going to just go through it quickly, because I will leave that. These are, so maybe, you know what, two ways again. One is wherein I kind of do all the maths and everything. Another is I explain the concept, so your fundamentals are strong, and then you go and practice these things on your own. So it will create interest for you, as well as make you learn something new. Okay, So at least for this, let me try this out if it works out like this, okay, for this course. So let's say I have a probability density function for some variable x, right, which is a line like this, right? But how I'm defining is, I say it is x by 2. But then my problem is that probability density function is such that the area under the curve should be not more than 1. It should be equal to 1 rather, right? So let's say I draw this probability density function. If you look at this, so what I'm saying is my value, it's a x by 2 function, right? So the value goes from 0 to uh, it keeps on increasing. So area of a triangle is what? Half into length into height, right? So if my half into length into height should be equal to 1, which means I can choose different kind of combinations here. So one of the combination is my it goes up to the value of 2, which means the height will be up to value of 1, because 2 into 1 into half makes it 1. So in case I want to say, I want to start from value of 1, okay, and the slope is x by 2, right? What will be this value of x1, so that I get a probability? What is the maximum bound? I can get some value, right? Because it is the area of the trapezium now, right? So I started off with such that so it at 1 the probability is x by 2, right? So probability density function values 1 by 2. So not probability. So I have to compute this value of x. So I can compute that. I assume some value. I say this, the length here becomes x by 2. Then the area of a trapezium formula I use, x1 by 2 plus half into this length, that is x1 minus 1, divided by 2 should be equal to 1. So I can compute 1, x1, right? Is this clear? So there is already a function called integrate in R, okay, which will allow you to do this, wherein I give the function. So all I need to do is I provide the function in it, for example x by 2, and I say lower bound and the upper bound. It will give me the value. What is the integral up to that value? Is this clear? So okay, so this is about the probability density function. So area between two bounds is what I'm interested in a probability density function, and then I can draw a cumulative density function out of it. How can I do that? I take the integral of my probability density function. In our case, the probability density function was x by 2, so the integral will be x square by 4, right? So I have so once I take the integral again, then I have lower bound and upper bound, right? Or not even in fact, in an integral function I don't need to have a lower bound. I just need to have single point, because what I'm saying is the probability of getting a value less than equal to that point wherever I choose, right? So for example, I say, what's the probability of getting maybe x is equal to half or less than half, right? So I can measure that using the probability density function. So things becomes easier because of integration and calculus, right? So you want to have a question on this? Giving you speaker rights. So conceptually, is this clear? Let me so for example, if I say integrate, right? So you can check this function out. So there's an inbuilt function. So I provide the function and then I say lower bound and the upper bound. It will give me the output, which is the integral of the function. All right. So is this thing conceptually clear to you? I've given you speaker rights. If it is clear, then I can move ahead. I would, the SWOL assignment, if you do, there are questions on this, but I've kind of, wherever you will end up facing some confusion, that I've already cleared up. Okay, so now quantile V of the cumulative density function is the point Vx at which CDF has value V. So now it is the reverse basically. What I'm saying is, all this while what we are saying, we have a cumulative density function. I say, what is the probability of getting a value? 2 or less than 2, right? Or 1.5 or less than 1.5. So it's a probability that I'm getting, right? What I say, I want to reverse it. I say, what is the value on the cumulative density function where the probability, so that the y-axis value is, let's say, 0.75. So the value that I'll get on the x-axis, that is what is the quantile, right? So quantile of is the inverse of that. So f of x of v is equal to v. So this is what is the quantile. Is this clear? is the point of quantile clear? Basically, I have two things. One is probability, another is some value. So when I know the value and I compute the probability, I do that straight away using the cumulative density function. So for example, I knew the V, then I say what is my xv and I get the value of fx. But if I want to compute V given fx, then I use the quantile concept. So I will show that using R. Don't worry about this, right? So for example, I say there's something called a random normal variable. I will explain that a little later. For now, just understand that it's a normal distribution random variable. You would know this much from whatever you've learned in stats earlier. I'm going to go into details of a normal distribution. But let's say if I say R norm, all right? So I say R norm 10. What am I getting? I'm getting 10 random variables here. You can see my screen? Yeah. So I'm getting 10 random variables here, okay, with different values. Now so there are different functions that are associated with the distribution for probability. I say P norm. P norm is the probability of, so basically it is equivalent to the cumulative density function. I say P norm, wherein he says mean is equal to 0, standard deviation is equal to 1, okay, for a distribution. And say what is the P norm of 2? What is the probability of getting a value 2 with a mean of 0 and standard deviation of 1? So I get, so 2 or less than 2, right? So I get 0.977, okay, which means that it is very highly probability that the value will be 2 or less than 2, right? On the other hand, the probability of getting a -2 or less than -2, which means -2, -3, -4 and so on, is very less. That is 0.02, which is kind of correct also, because the probability mean is 0, right? Standard deviation is 1, which means the value has to be more close to 0, right? 2 becomes really far away. But why were I getting 0.97 in the first case? Because it is adding everything. It is adding all the way from -infinity to 0. That is anyways half the probability. Then 0 to 0.1 to 0.2 to 0.3 all the way till 2. So therefore this probability becomes higher. Probability of getting anything greater than 2 would be very less. How can I compute that? I compute that by saying subtraction of this. I say 1 minus this. So I get this. And notice that they are the same as this, because normal distribution is such that it is symmetrically distributed. That's why we're getting the same answers. Is this clear? Huh? So now I get the probability norm. So P norm is equal to a CDF basically, right? Roughly equivalent to CDF. What if I was to do the other way around? I say what is the value associated with this probability, right? Say that's why we say quantile. For example, cat, right? Say percentile. So I say 95 percentile. What does 95 percentile mean? It means, so let's say 1 lakh students, let's say 1 million students gave the CAT exam, right? 95 percentile means that 950k students got marks. Okay, we will finish at 8:30. Don't worry. 8:30 is what we will finish the class at. Is that fine with you, Lavita? Yeah. So now what I'm saying is that I want to sorry, right? So cat 95, right? So I say 95 percentile, and 1 lakh people gave the cat, let's say, right? So which means out of 1 lakh people, 95,000 got less marks than what the guy who scored 95 percentile, less than, right? Than the guy who scored 95 percentile. So now same thing with this function called Q norm. So I say quantile normal distribution. So I give a probability here. I say what's the probability of values getting 0.5 or less? What is the quantile for 0.5 or less? Can you give me that answer? So I get 0, right? Because the probability of getting 0.5 or less is at 0, right? This will be a fixed value. I say 0.75 or less. Will this be an answer which will be greater than 0 or less than 0? It will be greater than 0, right? Because even till 0.5 I've already got 0. So I get 0.67. So if I was to take the value that is there written up there, I say 0.95, I get something like 1.64, right? I say 0.977, I get 1.99, very close to 2, right? So one is standard, my standard deviation was 1. So 2 standard deviations away, the probability is 0.977. So that's how it goes. So is this concept clear? What are we saying? What is a quantile? How is a quantile working out in terms of probability? So we have this new concept. So we have, one is probability mass function, another is probability density function, and then we have cumulative density function, and then we have the quantiles, right? So these are the concepts, introductory concepts. So can you please answer? I'm giving you speaker rights. Please answer. Is this concept kind of clear to you? You've understood that there are 4 concepts to be learned. One is probability mass function. Another is probability density function. Then cumulative density function, or you can say cumulative mass function, and then the quantiles.
Yes, Bhaiya, quantiles, we have studied already, but I forgot about quantiles.
Right. So
How to
basically,
take
quantile is
quantile
the
and all.
reverse of whatever we say. As I showed you here. What I showed you here is quantile. So right, so it is the reverse of
Yes.
the probability density, the cumulative probability density function. Okay,
Okay, okay,
yeah.
okay.
Anyone else? Any question? Any clarification? Okay, are you fine, Dipankar? You got it. Lavita, of course, is clear about it. And who was the one who spoke to me right now? It was Pratik or Chandramali?
Chandramal, sir.
Okay, Chandramali. All right.
Chandra,
So Pratik, yeah, Pratik and uh, uh, Dipankar, you guys are clear.
Deepankar.
Pratik is clear. Okay, Dipankar, are you there, Dipankar? Oh, see, on but not there. You guys should sit together, okay? It'll be better.
Yes, yes.
Maybe in one room, yeah? So you can sit in one room,
Yes.
connect your laptops. That's how you should do. At least two, three people at least. Okay. All right. So moving ahead. So now my probability model will typically have some assumptions that I'll make, okay? And now what I have is a population which is actually existing. And then there is data, which is what is observed by me, right? So for example, if I come back to the leaves of the tree, right? The population is existing, all the leaves are there. But I measure only 1000 leaves, okay? So that is my observed data. So what I happen is, let's say I wanted to find out the mean value, average length of the leaf. Now there is a population value, and that is the estimand. I call it the estimand. And then how do I, basically that's what I want to find out. It is the actual value, but it is unknown value, and that's what I'm interested in. Okay, how do I calculate it? I use a sample mean or sample median. Okay, and I call it the estimator. So my estimator gives me an estimate of the estimand. Is this clear? Just a terminology, that's all. We are introducing a new terminology here. Okay, and typically it is, how do I estimate things? I use some assumptions. We will look at all of that as we keep on moving ahead. So having said that, let's come to what is conditional probability. So I say probability of event A occurring, given that probable that event B has already occurred. For example, I say if the roll of a die gave me an odd output, what is the probability of getting a 3? You understood the question, no? So the probability of getting a 3 is that the choices are between 1, 3 and 5, right? So the probability of getting a 3 would be 1 by 3 now, as knowing that an odd event has already occurred. Probability of getting a 3 given an event has occurred, even event has occurred, will be 0, right? Because if it is an even event, the value has to be between 0, 4 or 6. It can never be 3. So this is what is conditional probability, and this is what is Bayesian rule also. What we say here is the probability of A happening given B has already happened is given by probability of A intersection B, that is A and B both, okay, divided by probability of B. So probability of both A and B, wherein B is like say event, odd event occurring, right? And probability of A is uh, so here I'm not saying that they are independent. If they were independent, then this would have become probability of A into probability of B, and then probability of B would be knocked out. All I will be left with probability of A. So when I talk about conditional probability, which means A is dependent on B, otherwise it will be straight away P of A. Is this concept clear? So now I'm saying this is my formula here. So for now, just assume that this is how it is. It says probability of A and B both occurring divided by probability of B. Say in this case, probability of A and B both occurring is what? Uh, which means that it should be odd. At the same time, the probability of having 1. Now, because probability of having, say, 3, right? So 3 is anyways included in odd event occurring. So, right? So probability of A intersection B will be equal to probability of A, right? Because A is anyways included in B, right? So if I was to draw it here, in this case, I would get something like this. So my B is here, and then A is within it. So probability of A intersection B is nothing but probability of A, right? So I can say this is equal to probability of A in this particular case. Okay, but this need not be all the time true. Similarly, I can rewrite it mathematically. I can say probability of B occurring given A has already occurred is again going to be given by probability of A intersection B divided by probability of A. So if I use these two equations 1 and 2, I get the simple Bayes rule. What does that say? Probability of B, because from this I get right, probability of B occurring given A has already occurred is equal to probability of A occurring given B has occurred into probability of B divided by probability of A, and vice versa. Is this fine? Basically what I'm doing is I replace this. I have this, and then I kind of substitute I basically take this here and I take it, shift it here. I substitute in this, I substitute this value, right? So is this clear? The base formula, I have derived it from this equation. All right. So, all right. So now what I can say is the probability of A occurring can be also written in terms of probability of B occurring or probability of B not occurring. So either B has occurred before A happens or B has not occurred. Only two possibilities. For each of the probable possibilities, I can say this. I can say, let's assume B occurred. What is the probability of A occurring after B has occurred? So I multiply these two. I get some probability. And then I say, okay, B has not occurred. What is the probability of getting probability of A happening if B has not occurred? So I get these two. So all of this combined will make the probability of A occurring, right? Is this equation clear? Equation C. Is the equation C clear to all of you? Let me hear this, because this is become
Yes.
yeah, okay.
Yes, bhaiya.
So okay, I think that's Chandramouli, right? So Chandramouli, it's clear. Who
Yes.
else? Okay. Anyone else? Dipankar, is it clear to you? Pratik, is this clear to you?
Yes.
Okay, right. All right. So now I use this concept, all right, this concept to come up with something. For example, what happens is you go for a test. Say that you have, you know, let's say jaundice, right? Say you have jaundice. You want to go for this test. Now, if no one goes for a test, let's say the mean value of people having jaundice on the planet is 0.0001, let's say, right? Which means the probability of me having jaundice, let's say not jaundice, because jaundice has visible symptoms, some other disease, uh, let's say abnormality of the heart, right? So some abnormality in the heartbeat. I have not done any test. I can't see my heart, nothing, right? And I know that that's statistically uh, 1 out of a million have a problem with the heart. Okay, so if I have not taken any test, my probability of that problem happening is 1 in a million, right? So now what I do is I perform a test, right? So this uh, uh, test is allowing me to come up with a better probability. So the test should tell me that once I've gone through the test, then the probability of me having that problem, if I don't have the disease, will be much lesser, right? So it was 1 in a million, maybe it'll become 1 in a billion, okay, for me. But if I have the disease, then the probability will be higher because it's still finally probabilities. Then the probability may become 1 in 1,000 or maybe 1 in 100, okay? So I say let's define two events. One is event D. Say that the patient has HIV, all right? And plus means the event that the patient is tested positive, right? So the event, say somebody goes through a test. He may not have the disease, but he may still the test might end up showing that this person has the disease, or the vice versa. He has the disease and the test may show that he doesn't have the disease. Okay. So now I have two things. So one is probability of testing positive given that the disease is there, okay, is known as sensitivity. So now higher this value is, that much accuracy is there in my test, right? The positives I have identified. Similarly, I want to be able to do the other way also. When I say the probability of finding the negative result when the patient doesn't have the disease, right? So this should be very high, no? Ideally, P of minus, given the disease is not there, should be equal to 1, right? That's what I want to reach out to. But I want that, but that's not practically possible. So I will have some value there, right? So now this is called the specificity of the test. So we just terminology again. So mathematical concept to be learned here is this. These are only concepts, okay? So now I can say probability, and this I can denote like this also. It's equal to 1 minus probability of mine not occurring given D, and similarly this, because that's just playing with maths here. So, do you want me to go through this maths? I don't think so. Do you think you can kind of, because this is something which you have to work out yourself. I will quickly go through this. So let's say I'm given these two probabilities. I'm given the sensitivity and specificity. So say sensitivity is 0.997, specificity is 0.985. Means what? There are say 0.003 chances that a person who actually has the disease ended up testing negative, means that he's not having the disease once he's gone through the test. All right, this is once he's gone through the test. Similarly, there are say 0.15 chances that a person who does not have the disease will end up showing the disease. Means what? So let's say initially the probability of anyone getting the disease is 0.001, all right, or probability of not having the disease 0.999, which means probability of me getting the disease given that I have the disease into the probability of the disease, right, would be what? This much, 0.009997. So without the test, my probability was anyways coming out to be 0.001. After the test, it's almost same if I have the disease, right? So I would yeah. So after the test, my probability will be, sorry, I would be 99.7% sure, right? So similarly, I can come. So basically, I can just do these mathematical computations. Now, what I want to find out is this: probably reverse of this. I'm saying what will happen actually. Now, this is what we can compute, but actually, when a patient comes, we don't know whether he has the disease or not, right? What is it? The only thing that we know? We only know that if we perform the test, the outcome of the test is positive or negative, right?
Yes.
Mathematically, we only know this much. Having known that, I say if the test showed out to be positive, what is the possibility, what is the probability that he actually has the disease? The test says he has the disease, but what is the probability that he actually has the disease? That is of interest. Are you getting this? In any test, that's the key thing. That's my area of focus, right? So that's what I have to compute. How do I compute it? Using the values that I've already computed. So if I put all of this, I get this value. So given that the test showed up that the person is positive, now suddenly the probability increases to 0.015. Means what? So there are uh, so 1.5% chances that he has the disease. Earlier there was only 0.1% chances. Without any test, it was only based on numbers. Now after the test, my probability has increased. Similarly, the reverse can be done, right? So what I'll do is I'll share this PDF with you. You guys can go through this, okay? And you understand this concept, right? So and then I can take the average of the two, just the little mathematics here, nothing very, the main concept is to learn that this formula, you have to understand it fundamentally. And then it is only the usage of this formula, okay? And then different terminologies. All right. So now, so these are all different terminologies only. What I see is that we will focus on basically learning the crux of things. Okay. Your quiz may still ask an answer, and for that, what you do is two things. So, particularly for this course, it's really amazing in the sense that there's a homework part to it, wherein they give the question and the answers are also there. So you can try out the question and do the answers. Okay. And then there is the swirl assignment, which will anyways explain things to you. So both of that you do it yourself, and both of them are interesting rather than having to read any theory. So theory and conceptual things I'm covering in the class. Okay. So you understand this. Okay. So I think we will stop here. So let's just recap what all we did today. Uh, Maybe the recap can happen from your side. Can you quickly do the recap? What all have you learned today? Pratik, Chandramouli, Devankar, Lavita?
Yes. Yes, Bhaiya.
Yeah. So recap of what all we have learned today. Quick, what all have you learned today?
Uh, about
What
the
new did you learn?
probability,
I just tell me what is new that
random,
you learned today? Okay.
about that quantile and that PEP norm, Q norm. And we actually have read it, but this time we have actually into depth in concepts of that. So
All
it
right.
was
So you
good.
understood it something more. Okay. Okay.
Yeah.
So what about the rest of you? Lavita, was there anything for you to learn in this class today, or was everything known to you, or some understanding became better? Lavita, Dipankar are there?
Yeah, but actually
Okay.
the conditional probability was something that I had to clear out. Uh,
Okay.
I'll do a couple of sums, it should make sense. The others, this was good, the base was good, so that we can move ahead once we've understood what's the difference between continuous and discrete probability
Okay.
distributions.
Okay. Right. Good. So yeah, so for Lavita, it was the usage of R to understand the same concept. Good. Okay. So good. So basically, what I see is that sometimes these simple concepts are in for especially for statistics. This is one subject where you should start understanding everything intuitively, and then mathematics supports it, and then R displays it. So three parts to it. You have to understand things intuitively, you have to understand it with maths, and then R will support it. R will actually show you, yes, this is how it is. R will show you many results, and the concepts will come much faster and clearer. Okay. So let me, we'll just wind up in another 2 3 minutes. I just want to show you what all you need to go through on your course. This thing. No, that's Chrome. Let me shift to Prime. So I would strongly recommend one is the Swirl programming assignment. Okay, I think there may be no marks to it, but go through it. And the second part is, so we have covered conditional probability up to 1, 2, and 3. So we've covered 1, 2, and 3. So you may want to go through. So tomorrow we'll cover the next stuff. Okay, go through either the videos, but more than the videos, it is these homeworks. All right. So this link is important, and I will send you my PDF. Okay. So go through this homework. Okay. Uh, so there are questions here. For example, he's asking these questions, right? So you solve these questions, you'll become better at things. Is this fine? Can you keep this as a work, enough work for today? Homework for the question.
Yes.
Maybe not all, because we've not have covered everything, but you do this and things will become better. It'll become really interesting. Once you try to solve at least one or two questions out of this. And second part is your swirl assignment. Okay, so go through this. For example, you go through the introduction, probability 1, probability 2, conditional probability up to here. Okay, so go through the first four of the conditional probability, or sorry, this for assignment, and a couple of questions in the homework part. Good enough?
Yes, Bhaiya.
Okay, great. Yeah. So anyone else wants to add anything? Good. Or shall we call it a day today? Maybe tomorrow again, same time, 6:30 we will start. Today took some time to adjust things and all. Please bring everyone else, and maybe they can watch the recording. You know, take responsibility over some of them. Say that they should watch the recording, because otherwise when they come to class tomorrow, they will not understand it. They will get disinterested. Okay, and you will be left with a smaller group. And once you're with a smaller group, then you also tend to lose interest. So as the big new year has begun, it is your responsibility that 12 of you people are there, together. At least 10.
Hmm.
Is this
Yes,
fine?
Bhaiya.
Okay. So
Okay.
each of you take responsibility for one or two people to talk to them to watch the video once I upload it.
Hmm.
Okay. Or they can
Okay.
sit with you and do these concepts. All right then. I think that's it. Anything else, Lavita?
Hmm.
Nothing?
No. So,
Okay then. Yeah. So you can leave if you're getting late. Those of you getting late can leave. Maybe if all of you have class, I guess all of you common syllabus, right? So everyone must be having class at 9, and then you have breakfast also to take. Okay.
yes.
So all right.